In chemistry, it's often useful to summarize details about our atom, and you will often see a symbol that looks like this. What do all these different things here mean? You notice we have 3 different numbers, and then we have some letters in the middle. Well, let's look at this symbol in the middle. This is what is known as an element symbol, and it represents the type of atom. As we continue through chemistry, you'll get very good at reading what these symbols are. In this case, Li is lithium. The next part of this symbol that we'll look at is this number down here. The number in the lower left corner is known as the atomic number. And if we look at our picture, let's see if we can figure out what it represents. Well, it's the number 3. What do we have 3 of here? Well, we have 2 electrons, 4 neutrons, and 3 protons. So the atomic number represents the number of protons in our atom. Now, because the number of protons does not change for an element, so an element that always has 3 protons is always going to be lithium. An atom that has 7 protons will always be nitrogen. That number is sometimes not listed, so sometimes you will see this number, this symbol without the number in the lower left-hand corner, because the number is always the same for a given element. So now let's look at the next number. We'll look at the one in the upper left-hand corner here. What is this number? This number is called the mass number. The mass number is going to represent the total number of nucleons or particles in the nucleus of our atom. So if we look at our atom, we see that we have 3 protons and 4 neutrons. So 4 plus 3 gives us the 7 for our mass number. Now you may notice that, well, what about the electrons? Don't they have mass? Well, they do have mass, but electrons are actually 10,000 times lighter than protons and neutrons. And so, because they are just so tiny compared to the protons and neutrons, we don't include their mass in the mass number. So again, the mass number is the total number of protons and neutrons in the nucleus, and can actually be represented by the formula protons plus neutrons equals the mass number. The final part of this symbol that we'll look at is this number in the upper right-hand corner. This number represents the charge of our atom. As we described before, protons are positive, electrons are negative. If we have the same number of protons and electrons, then our charge will be 0. If we have a different number of protons and electrons, then we're actually going to get a charge, and we have something called an ion. So this number again is the charge, and we can figure it out using this equation. Protons minus the number of electrons is going to equal the charge on our atom. Protons minus the electrons equals the charge on the atom. And this number is located in the upper right-hand corner of our symbol. A few terms that I mentioned while we were describing this term charge were ion and atom. What exactly is the difference? Well, an ion is just an atom with a charge. Since electrons are negative, if you have more electrons than protons, you have a negative charge. And if you have more protons than you do electrons, you have an ion with a positive charge. If you say you just have an atom, that means the charge is 0. The number of protons is the same as the number of electrons. So let's look at some examples of trying to figure out how many protons, neutrons, and electrons are located in different atoms. So at the top here, I've listed 3 different examples of atomic symbols. So we'll look at number 1. Number 1, we have the elemental symbol of O for oxygen. So in this box, I'm just going to write O for oxygen. Now its atomic number is located in the lower left-hand corner. So here's the atomic number. Its atomic number is 8, so that's what I'm going to put here. Its mass number is the number in the upper left-hand corner. This number is 16, so that's what's going to go in the mass number box. Now we have to figure out protons, neutrons, and electrons. Protons, as we said in the last slide, are represented by the atomic number. So since the atomic number is 8, then the number of protons will also be 8. The number of neutrons can be found because we know that the mass number is equal to protons plus neutrons. So we have to remember the mass number is protons plus neutrons. We know the mass number is 16. We know the number of protons is 8. So we have to solve for n, and we solve for n, we get n also equals 8. So in this case, we have 8 neutrons. In order to figure out the number of electrons, we need to look at the charge. We can see that it has a negative charge, which means we have more electrons than we have protons. So we can solve this in 2 ways. Well, we say because we have more electrons than protons, because this is a negative 2, we have 2 more electrons than protons, so 2 more than 8 is 10. The other way we can do this is the equation I gave on the previous page. Protons minus electrons equals the charge. So we have 8 protons minus, we don't know the electrons, equals negative 2. And then when we solve for electrons, electrons equal 10. Remember, the numbers for the number of protons, neutrons, and electrons must be positive numbers because we are counting the number of particles, and you can't have less than 0 particles. Pause the video now and try to solve number 2 and number 3 on your own. So now let's do number 2. Please check your answer to see if you're correct. So here we have carbon as our symbol, so we're going to put carbon as our element. The atomic number is 6, so we'll put that under the atomic number. The mass number is 12. Protons have to be 6. They're the same as the atomic number. Neutrons, 12 minus 6 gives us 6 neutrons. And then for the electrons, because we have a charge of 0, 6 minus 0 is 6. Whenever you have a charge of 0, you know that the number of protons equals the number of electrons. For number 3, this looks very similar. So again, we have carbon. It has the atomic number of 6. Remember that if we had carbon and the atomic number was anything different than 6, we would have made a mistake, because carbon has to have 6 protons. If not, it would be a different element. This time, though, its mass number is 14. The number of protons would be 6, and now 14 minus 6 will give us 8. When we do electrons, again the charge is 0, so protons and electrons are the same number, and we have 6 electrons. Now this might seem a little strange. How can we have carbon atoms here that have different mass numbers? Well, the answer is in the numbers of protons, neutrons, and electrons. We can have the same number of protons, 6 and 6, which makes it carbon, but the number of neutrons located in the nucleus are different. In carbon-12, we have 6 neutrons. In carbon-14, we have 8 neutrons. You may be asking, well, how can you have different types of neutrons? They're the same type of atom. But remember what we talked about before, the neutrons do not affect the type of atom. They also have no charge. So you can have the same type of atom with different numbers of neutrons. We actually have a specific name for these types of atoms. These are known as isotopes. An isotope, or isotopes, are atoms of the same element that have different numbers of neutrons in the nucleus. And, well, why does this matter? Well, neutrons help to stabilize the nucleus. So depending on the mass number of an atom, you could have a stable atom or an unstable atom. Unstable atoms do not have the right ratio of protons to neutrons, and eventually the nucleus will break apart. We're going to talk about these types of reactions where the nucleus breaks apart later in the year when we get to nuclear chemistry.